From the earliest times, humans have looked at the sun as both a god and an enemy. It gave warmth, raised crops, and lit the paths of caravans and sailors. Yet at the same time, it burned the eyes and scorched the fields. We are used to thinking of it as calm and almost eternal, like a golden background painted onto the icon of the sky. But behind this apparent stability hides a vast, boiling ocean of plasma, where storms rage that could erase our technological world in a single moment. Today, we know more about the sun than all previous generations combined. Space probes, like fiery moths, fly ever closer to it, measuring temperature, density, and magnetic fields. Missions such as Parker Solar Probe and the old but still legendary SOHO have shown us that our star can be truly furious. It does not merely shine. At times, it fires entire clouds of incandescent matter into space, coronal mass ejections, like blazing harpoons hurled across the void at millions of kilometers per hour. An ordinary solar flare is already powerful enough to disrupt radio communication and create auroras where they have never been seen before. But there are flares of another scale, super flares, explosions compared to which everything we have observed over the last 100 years sounds like a quiet whisper. The energy of such events can be thousands of times greater than that of typical flares. This is no solar whim. This is a cosmic catastrophe. Imagine that within the depths of the solar corona, monstrous tension builds up in magnetic lines, braided together like the strings of a gigantic harp. They twist and bend, storing energy capable of tearing the surface of the star apart. And then, in a single instant, the harp snaps. A flash, a release. A torrent of charged particles rushes toward Earth like an avalanche of light and fire. The first ooter comes silently, not with thunder, not with a visible blaze in the sky. It arrives through the ionosphere. Radio waves and navigation signals begin to behave strangely. Aircraft flying over oceans lose contact. Ships at sea watch their instruments go mad, as if their compasses had wandered into an enchanted forest. Satellites in orbit take the main blow. Their electronics are bombarded by particles traveling at nearly the speed of light. Some of them simply shut down, forever. In space, there are no walls, no roofs, no atmosphere to soften the ooter. For a satellite, a solar superstorm is like standing in a rain of microscopic bullets. Each particle can pierce a microchip, leaving a scar like a needle in thin glass. Navigation, communication, television, and orbital internet links, all of it is suddenly at risk. But the true drama unfolds lower, on Earth's surface. When the stream of particles reaches the magnetosphere, our shield begins to tremble like a sail in a hurricane. The magnetic field compresses and stretches, letting in energy it normally deflects. And deep in the atmosphere, a dance begins, like a grand ball of spirits made of light. Auroras spread toward the equator, painting the sky in green and crimson. But behind this beauty lies danger. In the long wires of power lines, induced currents appear. It is as if the planet itself turns into a gigantic generator. Transformers overheat. They begin to roar like enraged beasts. One by one, they fail. In 1989, a similar storm left an entire Canadian province without electricity. That was only a hint of what is possible. A true superstorm could plunge entire continents into darkness. Modern cities are nervous systems made of glass, concrete, and electronics. Elevators, pumps, cooling systems, medical devices, servers, all of them depend on the delicate breath of electricity. An outage lasting hours is already a problem. Days bring crisis. Weeks mean disaster. Refrigerators fall silent. Food supplies rot. Hospitals switch to emergency generators. But even they are not eternal. Financial systems freeze. Bank accounts become nothing more than numbers that cannot move. And all of this happens not because of war and not because of disease, but because of a distant star that rises every morning as a symbol of life. But what about the climate? Can a solar superstorm change the weather, melt ice, or burn forests? Here, science speaks cautiously. A single storm does not directly heat Earth's surface. The atmosphere absorbs most of the energy in its upper layers. Yet indirect effects are possible. Changes in stratospheric chemistry, damage to the ozone layer, a temporary increase in ultraviolet radiation. This is not the end of the world, but it is a blow to the fragile balance we rely on. History tells us that such events have happened before. In the middle of the 19th century, the so-called Carrington event took place. Telegraph wires sparked like fiery snakes, and operators received electric shocks. Auroras were seen even over the Caribbean. If something like that happened today, the damage would be measured not in millions and not in billions, but in trillions of dollars and in years of recovery. Data from space probes show that the sun is capable of even more, of flares that, in the distant past, may have been tens of times stronger than the Carrington event. Some astronomers find traces of such storms in the rings of ancient trees and in ice cores from Antarctica. In layers of ice and wood, the rhythms of cosmic catastrophes are written, like a chronicle carved in light. And here the question arises, does humanity have protection? Can we hide from the sun's anger? Completely no, but we can prepare. Modern observatories watch the sun constantly. They see active regions being born. They observe magnetic fields twisting and tightening. They can warn us hours in advance, sometimes even days. That is enough to shut down part of the satellite fleet, to shift power grids into safe mode, to save what is most valuable. We, the inhabitants of Earth, are used to fearing asteroids and comets, imagining the odor of a massive stone. But our true vulnerability lies elsewhere, in our dependence on electricity and signals. We have built a civilization on thin threads of current and data, and the sun, our ancient ally, can pull those threads in a single moment. Perhaps this is the main lesson. We live inside a star, not physically, but energetically. Every photon that touches your skin began its journey in the sun's core hundreds of thousands of years ago. Every electron in a wire obeys the same laws as the plasma in the solar corona. We are tied to this star far more deeply than we realize. A superstorm will not destroy the planet. It will not boil the oceans or melt the mountains, but it can reveal how fragile our technosphere truly is. It can briefly return us to an age of dark nights without screens or signals, where guidance comes not from satellites, but from the pole star. And perhaps it is in moments like these that humanity once again lifts its eyes to the sky and understands that it does not live at the center of the universe, but on a small island of light in an ocean of plasma and void. We often think of space as a distant stage where events unfold that have nothing to do with us. Supernovae explode, galaxies collide, black holes are born, beautiful, impressive, and safe, because it all seems so far away. A solar superstorm shatters that illusion. It reminds us that space is not somewhere out there. It is here. It breathes with us, presses against our atmosphere, stirs magnetic fields, and plays with our technology like a child with toys. When the stream of particles slams into the magnetosphere, Earth begins to resonate, not in sound, but in vibrations of fields our instruments can detect. The planet seems to answer the touch of the star with a deep, drawn-out groan. If we could hear it, a solar storm would sound like the music of an apocalypse. Not a melody of destruction, but a harsh anthem of nature's power. Humans are used to seeing themselves as masters of the planet. We build cities, lay roads, launch satellites, measure the distances to stars. Yet before the sun, we are still students standing before a teacher who can be gentle or suddenly raise its voice. One moment it gives warmth. The next, it tests our strength. Life itself on Earth exists because of solar energy. Photosynthesis, breathing, food chains, everything begins with light. And yet the same source of life can become a source of chaos. It is a paradox worthy of ancient myths. Once people would have said the god was angry. Today, we speak of unstable magnetic fields and streams of protons. But the truth is the same. We are facing a force far greater than ourselves. Imagine the night after a superstorm. The city is plunged into darkness. The sky, usually drowned in artificial light, becomes deep and black, like in pre-industrial times. Stars blaze brighter than ever. The Milky Way stretches above rooftops like a silver river. People step outside, and for the first time in years, look upward not for forecasts or satellite maps, but simply to understand where they are. In that moment, it becomes clear. The sun is not just a lamp above our heads. It is the heart of the system we live in. It pulses, sometimes losing its rhythm, and every disruption echoes through our networks, our screens, and our lives. We can build shields from algorithms and transformers, harden satellites, and predict space weather. We can learn to shut down vulnerable systems in advance, like closing windows before a storm. But we cannot cancel the storm itself. It is part of a vast cosmic decania that has lasted for billions of years. A solar superstorm is not the end of the world. It is a reminder. A reminder that civilization is a thin layer of order laid over a chaotic universe. That even our most advanced machines still depend on the moods of a star 4.5 billion years old. And that humanity's future is not only about rockets and colonies, but about learning to live in harmony with cosmic forces. When we talk about protection from solar storms, we are really talking about growing up as a species, about moving from naive confidence to careful understanding, about realizing that intelligence is not only the ability to create, but also the ability to foresee. Perhaps one day our descendants will live under domes on Mars or aboard orbital stations, and solar storms will be as familiar to them as thunderstorms are to us. They will activate protective systems, wait out the radiation, and step back into the light. And then the sun will no longer be a threat, but a partner in a long dialogue between star and mind. For now, we live on the fragile surface of a planet protected by a magnetic shield that endures blow after blow. We watch the auroras and marvel, often forgetting that they are the glow of a struggle between Earth and its star. And in that glow lies the full drama of our place in the universe. We are small, yet capable of understanding the immense. Thank you for taking this journey through solar fury and human vulnerability with us. If you enjoyed it, support the channel with a like, share your thoughts in the comments,